Hi everyone, this is Mrs. Terigno and this is page 4 of the Geometry C semester exam review packet. What I've done here is I've actually taken the page that's in your packet and blown it up so that you can see it here on camera. So if it looks a little bit different than your page 4, that is okay. This video is actually going to cover pages 4 and 5, so it'll cover questions 14 through 19. And then this first page has questions 14, 15, and 16 on it that we're going to talk through right now. Okay, this chunk of your exam review is all about the logical reasoning questions that we talked about. And number 14 is one of the ones with sort of the nonsense words, the words that don't really mean anything. But that's okay. You don't have to know what the words mean to apply the laws of logic. And that's what's so great about using those laws of logic. So you're given some information here. You're given that all NERCs are Larses. You're given that some Guozos are NERCs. You're given that all Larses are purple and that Bogwats are purple or yellow. Okay? And then it's asking you if these things are true or not. Keep in mind that if you say they're not true, it's really not that you're saying they're not true. It's that you're saying you don't have enough information to tell whether or not it's true. So false is really like saying, I don't know. Okay? We only want to say true if we are absolutely positive that our result is true. So the very first one it's asking about is it true that all Guozos are Larses? Well, I know that all NERCs are Larses, and I know that some Guozos are NERCs. But the important thing to pay attention to here is that only some Guozos are NERCs. Okay? So the Guozos that are NERCs would also be Larses, but not all of them are. And this statement says that all Guozos are Larses. So this one I would label as being false. Okay? Because we only know that some Guozos are NERCs, and then those NERCs would be Larses. Okay. Next it says all NERCs are purple. Well, we know all NERCs are Larses, and we know all Larses are purple. So I would say that makes sense. Let's diagram that out just so you can see what I'm talking about. I know that if you're a NERC, then you're also a Larse. And if you're a Larse, you have to be purple. So by the law of syllogism, which was that fun law that we talked about in chapter 2, I know that if you're a NERC, you would have to be purple. So this one I would say is true. Okay. Now the next question is really asking us to work backwards. Because if we know that all NERCs are purple, if you're purple, do you automatically have to be a Larse? Well, not necessarily. Remember when you're doing if-then statements that your arrows can only go in one direction, all right? Because this says that if you're a Larse, you have to be purple, but there could be other things out there that are purple that are not Larses. In fact, there's an example right here. It says that Bogwats, whatever the heck those are, Bogwats could be purple or yellow. So in this case, I would say that this is false because there could be other things that are purple besides Larses. Okay. Question D says, Bogwats are Larses. So let's look at the only thing we know about Bogwats. This only gives us that Bogwats are purple or yellow. Okay? It doesn't tell us anything about whether or not that would make it a Larse. And like I said just a second ago with question C, even if it was purple, that wouldn't necessarily mean it had to be a Larse, okay? Because these arrows in this diagram that we drew up here don't work the other way. So a Bogwat doesn't necessarily have to be a Larse. I suppose it could be, but it doesn't have to be, so I would say false. And then the last statement, that some Guozos are yellow. Well, I know some Guozos are NERCs, and NERCs are Larses, and Larses are purple. But, so the Guozos that are NERCs would have to be Larses, and those Larses would have to be purple. but I don't have any information that would lead me from guozos down to yellow. I suppose it's possible, again, that they would be, but I don't know for sure based on the information that I'm given. So I would also say that that one is false. Hopefully that made some sense. I know we tend to struggle a little bit with those ones that are made up words because we can't really picture what these things are in our head. But you really just have to follow what information you are given. And the thing that's helpful about these problems where the words are made up is you can't accidentally bring in outside information. Remember, in a problem like this, you just want to focus on the information that's given to you. And if you don't know what the heck a NERC is, there's no way you can bring in outside information. So hopefully that will help a little bit. Okay, question number 15 is asking about counterexamples. Each one of these statements is written as an if-then. So it's if blah, 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 then blah, blah, blah. Okay? A counterexample is a situation where the if part is true, but the then part is false. So just to keep your focus throughout this, we want the if part to be true, and we want the then part to be false. Let me show you what I'm talking about here. The first statement is, if it is 9:15 a.m., then you are in second hour. So we need to think about a way that it could be 9:15 a.m. We want this to be true, but that we would not be in second hour. We want this part to be false. Okay? So a situation where it would be 9:15 a.m., but you would not be in second hour. And you just need one situation where that would be true. For example, what if it was Saturday? If it was Saturday, it could be 9:15 a.m., but you wouldn't necessarily be in second hour. In fact, I hope you wouldn't be in second hour because I wouldn't be there. Okay, so there's your counterexample that on Saturday it could be 9:15 a.m., but you would not be in second hour. Okay, question B. If it is summertime, then it is July. Again, for a counterexample, we want this to be true. So we want something where it is summertime, but we want this to be false. So we want summertime that is not July. So does it have to be July if it's summertime? No. It could be June, it could be August. But remember, for a counterexample, you just need one of those. So I'm just going to pick one situation where it would be summertime, but not July. August is in summertime, but it's not July. Okay, the third one is a little more mathematical. If x is less than 3, then x is greater than 1. So I need a number that is less than 3, but that is not equal to 1. So I need less than 3, not equal to 1. Well, there's an infinite number of numbers that are less than 3 because you could even go into the negatives, okay? I just need to pick one that's not equal to 1. What about 0? I could say x equals 0, and that would be my counterexample. Now, we might not all pick the same counterexample, and that's okay. You just need one situation that would show an instance where this is true and this is false. Okay? Hopefully that clears up the counterexample business. Okay, question 16 wants us to refer back to these statements and write the converse of A, the inverse of B, and the contrapositive of C. And then we have to go back and figure out which ones are true. So I'm going to take these statements and write them on a separate sheet of paper so that you can see them. Okay? Excuse the fancy stationery here. Okay, if you look back at problem 15, and I know you can't see it here on the video, but hopefully you have it on your paper. Question A says, if it is 9:15 a.m., then you are in second hour. So I'm asked to write the converse of that statement. And I guess before we talk about a converse, we should talk about a conditional, which is an if-then statement. Okay, a conditional, we always say, if P, then Q. And remember, oh, I'm sorry, you can't see that. There we go. So a conditional statement or an if-then statement is always if P and then Q. Okay, so if it is 9:15 a.m., then you are in second hour. The converse is when I reverse those, so Q and then P. So I want to take the two pieces of those statements and reverse them. And here's what that would look like. I would say if it is second hour, then it is 9:15 a.m. Okay. If it is second hour, then it is 9:15 a.m. Okay? That would be my converse because I reverse the order of the two pieces of my statement. I reverse the hypothesis and the conclusion. Now, I want you to think about that statement for a minute and decide if that's true or not. If it is second hour, does it have to be 9:15 a.m.? Or can you think of a way it could be second hour and not have it be 9:15 a.m.? Well, second hour goes for a whole hour. It goes from 9:05 to 10:05. So there's a lot of times in there where it could be second hour and not be 9:15 a.m. So I could come up with any counterexample for this, but the bottom line is this statement is false. Okay. All right, let's look at B. Again, I'm going to put my conditional on here. Conditional is if P and then Q. For statement B, that is, if it is summertime, then it is July. And question 16 is asking me to write the inverse. The inverse is where you leave these two where they are, but you negate both of them. So it would be not P and not Q. Okay? So I still want to keep summertime first and then July second, but I'm going to negate them. So I would say, oh, this is letter B. If it is not summertime, then it is not July. Okay. So I kept the statement exactly the same. I just introduced the word not into the hypothesis and the conclusion. Now to decide if that's true or false, think about this. If it is not summertime, so think of a time that is not summertime, then it is not July. Is there any way it could be not summertime and still be July? And I know these ones with the nots in them are a little bit tough to work out in your head. There's a lot of negating going on. But if you know, if I tell you it is not summertime outside right now, which it's not, evidenced by the inches of snow that are falling right now, if you know it's not summertime, is there any way that it could be July? And I suppose if we were going to get technical and talk about, well, down in Australia, it could be, I would take that as a counterexample. But I would say that if we're sticking to the United States here, that this one would be true. Okay? If it's not summertime, you know it can't be July. That's true. Okay, on to question or letter C. Again, my conditional is P and then Q. And I'm just putting that so you can compare it to what the contrapositive looks like. The contrapositive is sort of like the converse and the inverse put together. Okay. So it would be not Q and then not P. So this time I'm reversing the order and I'm negating both parts of the statement. Okay? So right now the statement says if x is less than 3, then x is equal to 1. Here's what the contrapositive would look like. This is for letter C. And I would say if x is not equal to 1, then x is not less than 3. Okay? You could actually even say this. Instead of saying x is not less than 3, you could say x is greater than 3, because that's the only way you could be not less than 3. So, if you know for sure that x is not equal to 1, do you also know for sure that x is not less than 3? And let me word that in a different way. Let's try to think of a counterexample. Can you think of a number that is not 1 that is less than 3? Well, that counterexample probably works along the same lines as our original counterexample. Remember that originally we said our counterexample was x equals 0. Well, 0 is a number that's not equal to 1, so this part is true. But it is less than 3, so this part is false. So that's a counterexample, which means that this statement would be false as well. Okay, so that does it for question number 16. Let's jump back into your packet here. And I'm actually going to flip to problem number 17, which is page 5. And again, I've blown up the font here so that you can read it from there, hopefully. Okay, so again, it might look just a little bit different. This is asking you to tell the difference between deductive and inductive reasoning. Remember, inductive reasoning is when you're basing your conclusions on a pattern or an observation. And deductive reasoning is when you're basing your conclusion on a fact or a rule or a theorem. Okay? So this first situation, Holly is making a casserole, and she refers to a recipe to determine which ingredients to add. I would sort of consider that recipe to be like a rule. Okay, it's giving you a list, it's giving you directions, it's telling you what to do. So if you are given factual information like that, this would be deductive reasoning. Okay. Now, if it said Holly is making a casserole and she throws in what she thinks needs to go in there, or she tastes the casserole and decides that she thinks it needs more salt, that would be more like inductive reasoning. But here, since she's following a rule, I would call that deductive reasoning. Question number 18 asks the same thing. It says that Jamie says no every time her friends invite her to the movies, so her friends conclude that she must not like the movies. Well, her friends are basing their conclusion on a pattern. They're seeing that every time they ask, she says no. So they're basing it on an observation over time. That would be inductive reasoning. Okay. Hopefully that clears up the difference between the two. Deductive reasoning is always based on rules, and inductive reasoning is based on observations or patterns. Okay? Okay, question 19, talking about some more conclusions. And you're given a lot of information here about Katie. It says Katie has cheer practice on Thursday afternoons. Whoops. Cheer practice ends at 6:30. After cheer practice, Katie and her mom always go out to eat at her favorite restaurant, and Katie always orders the chicken fajitas at her favorite restaurant. I'm going to take just a minute and sort of diagram this information out for you. Okay, so taking that first statement, Katie has cheer practice on Thursday afternoons. If I were to write that as an if-then statement, I would say if it is Thursday, then Katie has cheer practice. Okay? And we're just going to add to this diagram as we read through the rest of our information. And then we'll use the diagram to answer these questions. Okay, so that took care of the first one. Cheer practice ends at 6:30. So if she's at cheer, we know that it ends at 6:30. Okay. After cheer practice, Katie and her mom always go out to eat at her favorite restaurant. So that doesn't really branch off from ending at 6:30. That branches back off from if she's at cheer practice, we know she goes out to eat at her favorite restaurant. Okay, so if she goes to cheer practice, she ends up eating at her favorite restaurant. And when she goes to that favorite restaurant, she always orders the chicken fajitas. All right, sorry for that messy handwriting down there in the corner. But this is sort of a diagram of this situation, and I would really recommend for problems like this that this is how you start it. Okay, you guys did a much better job with this type of reasoning once we learned how to diagram these out. So if it is Thursday, then she has cheer practice. If she has cheer practice, it ends at 6:30. We also know that if she has cheer practice, she eats at her favorite restaurant and she orders chicken fajitas. So if we know that today is Thursday, what else do we know? Well, we know all kinds of things. And really, when I'm asking you for your conclusion, you just want to give me the end conclusion from each branch. But if you listed the stuff in between, that wouldn't be wrong. So if it's Thursday, we know that she has cheer practice and it ends at 6:30. So we know that she's being picked up at 6:30. And like I said, if you had also written that we know she has cheer practice, that would be okay too. We also know that if it's Thursday, if we follow this path, she's going to end up eating chicken fajitas. And again, you could also add in there that you know she's going to eat at her favorite restaurant. But really, conclusions are talking about sort of the end of the road conclusion. Okay, and I would say that's as far as we can get from Thursday. We can get to the end of this route, and we can get to the end of this route. Okay, if we know Katie is eating chicken fajitas, that means we're standing down here at chicken fajitas. Can we move backwards along this path? The answer to that is no, because we don't know anything about working in the opposite direction. None of these are biconditional statements, which means we can't move along them in both directions. If she's eating chicken fajitas, she might be eating chicken fajitas at home on a Tuesday night. So we can't make any conclusions from here. There's no place to go. So here I would say no conclusion. Okay. Katie is at cheer practice. So Katie is right here. What do we know? Well, we know she's going to be picked up at 6:30 or that it ends at 6:30. Either one of those would be correct. We also know that she's going to end up eating chicken fajitas. Again, I'm just going all the way to the end of the road with those. But remember that if you listed that stuff in between, like if you said that you also knew she was eating at her favorite restaurant, that would be okay. What you can't say, what would be wrong, is to say that you know for sure it's Thursday. Notice that that would be working against the arrow. Okay? Maybe she has cheer practice on other nights of the week too. This says she has it on Thursdays for sure, but maybe it's on other days as well. Maybe she has Tuesday night practices. Who knows? Okay. And Katie and her mom are going out to eat tonight. This one's a little bit tough because it doesn't specify where they're going out to eat. If we knew for sure that she was eating at her favorite restaurant, we could say that she would order the chicken fajitas. But it doesn't say where they're going out to eat. So we can't even start here. We don't know this for sure. And we certainly can't work backwards and say that that must mean she was at cheer practice because we can't work backwards in our diagram. We know they go out to eat when she has cheer practice, but maybe they go out on other nights as well. So this one I would also say no conclusion. Okay. That does it for this segment of your semester exam review. Stay tuned and we'll pick up with problem number 20 in the next video.